Hello everyone, this is Professor Munir from Chemistry Department AMU Aligarh. The course which we have been put up is the organic photochemistry. I hope you have already looked the the lectures which have been put up. And in the initial, uh, the lectures, what we have discussed is the principles or basic aspects of photochemical reactions. As I have mentioned, when we are talking about photochemistry, what is it all about is the interaction of light, which light is important, how much amount of energy in terms of kilocalorie per mole we are giving, what happens when we shine light, and so on and so forth. And later on, we have discussed the photochemical reactions of few, the chromophoric organic molecules, the photochemistry, steady state photolysis of organic molecules like alkene, 1,4-diene, and 1,5-diene, carbonyl compounds, alpha beta unsaturated compounds, aromatic compounds, and so on and so forth. So if you have any clarification or any doubt, please come up and so that we can discuss and hello. You can, if you want to say anything, you can raise your hand and so that I can unmute. Hello. So you want me to go on speaking or share some slides or what? What is you think? Because I don't think I could see here only three attendees and nobody is responding or nobody is asking anything. Uh, mhm, mhm. No, because if there is some feedback from other side, say for example, see I could see here three people here, Chandu, UV, and Nagalla, so, and then Pushpa Ultha. So these three. Uh, if uh, if they have if they have gone through the lectures and if they have any doubt, then I can, because this will be the same thing which I have done in the slides. So just sit here like that, or just go on speaking. Hmm? Okay, okay, yeah, yeah. Okay. Right. Now this will be more advisable if students have any doubt, any clarification of my in my slides so that I can, or any question raised by them. And yeah, okay. Sure. But I can ask them whether I am audible to them or not. That's audible. Okay. Okay. Okay, so as I have mentioned in just now, we have in the initial lecture we have also talked about the type of photochemical reactions based on energy profile diagram of the ground state as well as excited state. So photochemical reactions have been classified into three types: adiabatic, non-adiabatic, hot ground state. We have also discussed the basic laws of photochemistry, means the only those molecules which absorb light undergo photochemical reactions, or any light which is reflected or does not bring any photochemical reaction. We have also mentioned in the in few of these slides. Uh, Hello, I'm audible to all of you. If you have any questions, any doubt, please raise your hand so that we can discuss if you need any clarification or right. Okay. Yes, please. Hello. Yeah, please. Yeah, go ahead. You want some to ask something? Hello. Yes.
Hello, sir. Good evening, sir.
Yes, please. Yeah, speak
Hello,
louder.
sir.
Yeah, speak louder.
Sir, sir, sir.
Uh,
Third assignment, fourth assignment, fifth assignment ఉన్నాయి sir.
Sorry.
Sir, assignment third, fourth,
Uh-huh.
fifth are very critical, sir. Please
Uh-huh.
send material, sir.
Mhm.
Hello.
Yes, please.
Sir, assignment third, fourth, fifth are very critical, sir. Please send material, sir.
Okay. Assignment. Which assignment?
Third, fourth, fifth, sir.
Third, fourth, and fifth assignment is critical, you mean?
అవును sir. Yes, sir.
Yes. What is the problem in that one? Actually, those assignments are uh, third and fourth and fifth. Actually, based on the all the examples have been, if you have looked the slides of lectures,
Okay. Okay.
all the no exam, no, has been nothing is from outside. All the problems have been discussed. Say for example, you have the starting material, and when you shine light, what what type of photochemistry this particular compound will undergo, right?
Madam, namaste, madam.
Yes, sir.
Yeah. Assignment.
Sir.
Yes.
అదే ఒకసారి మెటీరియల్ పీడిఎఫ్ ఏమన్నా అది షేర్ చేస్తారని సార్ ఏమన్నా ఇంకా అదర్ మ్యాటర్
You mean material for assignment 3 and 4?
అవును సార్ ఎస్ సార్
Sorry, speak again.
ఎస్ సార్ ఎస్ సార్ థర్డ్ ఫోర్త్ ఫిఫ్త్ సార్
Third, fourth, and fifth. Okay.
అవును సార్ ఎస్ సార్
Assignment for third, fourth, and fifth. Okay, I will just note down. I will see what
ఎస్
type
సార్
of what are the problems which are given in that one, and then we can discuss. Right?
ఓకే ఎస్
Assignment third, fourth, and fifth. Right? Okay. Anything else? Anything else, please? Any clarification, any doubt? If you have any in my lectures of on organic photochemistry, please go ahead. वाईफाई बार बार डिस्कनेक्ट हो रहा है। ठीक है, आ गया। Hello? Yes.
Hello.
Yes, please.
Yes, sir. Sir, at the fourth, fifth assignment ఉన్నాయి కదా సార్ అవి. మెటీరియల్ ఏమైనా అనదర్ మెటీరియల్ ఏమైనా సెండ్ చేస్తారు సార్? డీప్ గా ఉండే మెటీరియల్.
What is the doubt? Tell me again.
హలో.
Yes.
3, 4, 3, 4, 5 సార్ అసైన్మెంట్స్.
Yes.
క్రిటికల్ సార్, క్రిటికల్ గా ఉన్నాయి సార్ అవి. క్రిటికల్ సార్, వెరీ క్రిటికల్ సార్.
Okay.
ప్లీజ్ సెండ్ మెటీరియల్ సార్.
Okay. Okay. I just noted your query, and then I'll put up some, I mean, supporting material for these assignments, right?
అవును సార్. ఎస్ సార్.
Yes, I have noted your clarification, and I will just look into the assignment 3, 4, and 5, and
ఎస్ సార్.
the supporting material for these assignments will be
Yes,
conveyed
sir.
to you, right?
ఎస్ సార్.
Yes.
థ్యాంక్ యూ సార్.
Okay. Anything else? Any other clarification, please? Any doubt, any clarification? Okay. So, after, as far as my lectures on photochemistry is concerned, after the basic principles involved in photochemical reaction, we have looked into the photochemical reactions of alkene, which mainly undergo cis trans isomerization, and in few cases, when the two substituents are properly substituted in the cis orientation, then there is a possibility of 6 pi electron cyclization. So we have also looked into this, such as trans estylbene going to cis estylbene. The two phenyl group in cis orientation can undergo 6 pi electron cyclization, and then to give you dihydrophenanthine type reaction. So, and also we also looked into the dibenzoyl alkene rearrangement, where phenyl group migration can also take place in the case of dibenzoyl alkene. After this, we discuss about the photochemistry of 1,4-diene. 1,4-diene is undergo a very interesting photoreaction when what we call is as two double bonds separated by a methylene group can, if they undergo very I mean important rearrangement called dipymethane rearrangement, when two double bonds are separated by a methylene group, and then it undergoes dipymethane rearrangement to give vinyl cyclopropane as the product. So an open chain system giving rise to a three-membered ring. So this is a very important rearrangement, because construction of three-membered ring is not very easy because of the ring strain present in these cases. So this this 1,4-diene undergo vinyl cyclopropane to give propane ring system. Of course, a 1,5-diene can lead to the formation of 1,3 sigma tropic shift under photolytic condition, and or under thermal condition it can also go what we call is a 3,3 sigma tropic shift or a Pope rearrangement. Hello? Am I audible to everyone? Hello? Okay, so after discussing with the photochemistry of 1,4-diene, 1,5-diene, and then we also no later on we looked into several examples of carbonyl compounds. Uh, Aliphatic carbonyl compounds undergo Norris type 1 and Norris type 2 reaction. Norris type 1 is a simply a alpha bond cleavage which gives carbon central radical and acyl radical which undergo decarbonylation, and then the combination of radical species to give higher alkanes. But some alicyclic ketones, Norris type 1 reaction is very uh, uh, prominent and gives a very interesting product in the case of alicyclic ketones, where alpha bond cleavage takes place, and if alpha carbon is substituted, then then the more stable carbon center radical is going to form. Hello? Am I audible to everyone?
Yes, sir, you are audible. You can keep continuing.
Any clarification, any more doubt? I just noted the from one they said assignment 3, 4, 5. They are very critical. So some reading assignments are required for this. Anything else you want to? Any more clarification or more doubts which we can? So this session is for whether you have looked when you have gone through my lectures, are you which are the portion where you have a doubt or where you need some clarification so that we can discuss those things here. Hello? Okay. Okay. So after going through the what we call is the as we have also mentioned that the photochemistry of carbon compound have got 4 different types of photoreaction. Norris type 1 reaction, Norris type 2 reaction. Norris type 2 reaction is gamma hydrogen abstraction. Excited carbonyl abstract gamma hydrogen to give 1,4-diradical. This is again a very important reaction because there is a formation of a 4-membered ring system. So whenever there is a possibility of formation of a ring constraint system, it is always a very challenging and important reaction where because these are not very difficult. These are very difficult to construct strain ring system. So such just like dipyrmethane rearrangement, we are constructing 3-membered ring. Norris type 2 reaction gives 4-membered ring, cyclobutanol as one of the product, and of course some cleavage product. Then photoreduction and Paterno-Bucchi reaction. Photocycloaddition of carbonyl to alkene have also been discussed where we are constructing 4-membered with oxygen containing heterocycles. So that is also a very important because uh, we get a heterocycle with 4-membered ring, and a lot of work has been done and several examples have been reported, and so on and so forth. So as far as the type 1 in alicyclic ketone is concerned, I have also mentioned that it is not possible to it is not possible to generate radical on the cyclopropane ring, and also it's also difficult to generate radical on sp2 hybridized carbon, I mean double bond. So when such double bonds are there, so radical will not generate on the cyclopropane ring, and also it will not generate on the double bond. It will generate on the other bond cleavage takes place. So these are the two exceptional cases where the radical generation is not important. Okay, another later on we have also discussed the photochemistry of alpha beta unsaturated ketones like cyclohexadienone, uh, monoconjugated as well as cross conjugated alpha beta gamma unsaturated carbon compounds, some photochemistry of aromatic compounds. We have also discussed the what we call it as the photochemistry of yeah, I mean some named reactions. We also nucleophilic reaction of uh, I mean the anthracene with diphenyl acetylene. And so then photochemistry of those compounds have been. In continuation, we have also discussed the photo-induced electron transfer reaction. Also mentioned initially that the photo-induced electron transfer reactions can be of two types. Uh, is a homogeneous photo-induced electron transfer reaction as well as heterogeneous photo-induced electron transfer reactions. Homogeneous induced electron transfer reaction where donor acceptor both are soluble is a one-phase reaction, and a lot of work has been done with the donor should be an electron-rich species, and acceptor should be electron deficient like dicyanobenzene and dicyanoanthracene and so on and so forth. Hello, am I audible to you? Hello. Yes.
You are audible, sir. Your voice is
Okay.
coming fine.
So I just go on speaking like this. If you there are how many who are there? Yes, uh, Mr. I could see here Chandu, Mr. Chandu, and then Manikanta, Nagala, and Pushpa. You need any question, any more clarification in my lectures on organic photochemistry? Hello. If you this session is for interaction. For if you find any difficulty in understanding or any yes. Hello. My I'm audible to all of you. Is it clear? I could see here clarify your voice. Is it is not clear? My voice is not clear. Hello. Okay. So what I was discussing here is the photo-induced electron transfer reaction can be of two types. So photo-induced electron transfer reactions are two types. Homogeneous photo-induced electron transfer reactions where we have a donor and an acceptor. So in the presence of light, Donor is an electron-rich species. Acceptor is electron-deficient species. Donor transfers electron and acceptor accept an electron. Donor becomes radical cation, acceptor becomes radical anion. So we generate a radical cation and radical anion species, which on further reaction can undergo. These are this is a one phase reaction where both are soluble, and one of the most important, I mean, one of the example is the tetramethyl reacts with dicyanobenzen or dicyanoanthracene. So dicyanoanthracene becomes radical anion and tetramethyl becomes radical cation. And then they can once again react together to give different products. Similarly is the photoreduction. Photoreduction of carbonyl is another example of homogeneous photo-induced electron transfer reaction, where reduced to carbonyl gets reduced to alcohols under photolytic condition under protic solvent. Hello, am I audible to everyone? Chandu is mentioning that my voice is not clear, so I don't know whether it's a problem with, uh, with his connectivity or my. Okay. Okay. Another photo-induced electron transfer reaction is the heterogeneous photo-induced electron transfer reaction. These reactions I have also discussed in great detail, where and one of the most famous example in heterogeneous photo-induced electron transfer reaction is the semiconductor mediated photo-induced electron transfer reaction. Semiconductors such as cadmium sulfide, titanium dioxide, zinc oxide, these are semiconductors and they are characterized by hello. Okay. These materials like zinc oxide, cadmium sulfide, they are characterized by filled valence band and vacant conduction band, and there is a band gap energy. And if we shine light, give energy in terms of light greater than or equal to band gap, there is a electron excitation from valence band to the conduction band, and thereby generating electron hole pair. These electron hole pairs, or in other words, we call it as the generation of oxidation and reduction sites on the surface of the photocatalyst. Or we can bring about oxidation reduction reaction. Or in other words, if we do the reaction in the presence of water and oxygen, then these oxygen picks up this electron, becomes superoxide radical anion, and water gives an electron to the hole followed by loss of a proton to give hydroxyl radical. So in other words, we generate hydroxyl radical. Yes, I noted your message. That third, fourth, and fifth assignment is very critical. So related material to be supplied. So I'll just I'll look into this and uh, and attend to this assignment. Right? Just anything else, please. I have noted your this query. Anything else, please? Okay, so no. I'll just very quickly share some of the slides very quickly. These are the few examples of cis-trans isomerization. The in the presence of light is always the reaction is always trans. I mean always in equilibrium. Is it not possible to convert more stable trans to less stable cis? Because trans is more stable than, so it is a non-adiabatic type reaction, but it is possible to convert thermodynamically more stable trans to cis, and then the mechanism is very clear, very simple. It's going to cleavage of double bond in the presence of light to a diradical species, and then which will combine to give a cis isomer. These are the uh, few examples of cis trans isomerization. Fumaric acid going to malic acid, trans is still being going to cis is still being, azobenzene going to cis azobenzene. There is also possibility of the 6 pi electron cyclization. So here you can see is nicely set for 6 pi electron cyclization under photolytic condition to give you dihydrophenanthrene, and then this dihydrophenanthrene can go to a more stable aromatization by simple air oxidation. Okay, these are another examples of cis-trans isomerization followed by cyclization. This is again a very important reaction of cis-trans isomerization followed by cyclization is a steroid called techisterol, which under photolytic condition can go to Z isomer. This is a provitamin D2, then cyclize 6 pi electron cyclization to give a numisterol. And then this is a photochemical reaction. This is also a photochemical reaction. And then this is a thermal reaction going to vitamin D2. This is again a photochemical cis-trans isomerization. There's two benzoyl group in the cis orientation can undergo phenyl group. The excited carbonyl adds to phenyl to give this type of intermediate, a ketene intermediate, highly unstable, can decompose in the presence of water to give an acid, or it can decompose to give an ester. Then is an example of a dipymethanium. Hello? Can you see the slide, please? Hello? I've shared a slide. Is the slides are clear? Hello? Okay, so this is an example of the photochemistry of 1,4-diene. This is a basic skeleton of 1,4-diene. Under photolytic condition can go to 1,2-di radical, and then the cyclopropyl radical, and then cyclization. So you can see an open chain going to the cyclopropane ring. Hello? Is it is the slides are clear? Can see the slide, please? Hello? What's up? Right here. Slides उसके ऊपर वापस से उसके
आपको स्लाइड शेयर करनी है
कर दिया, तो ये हम वापस लाना है वही नोट दोनों से। हाँ ठीक है, अब
आप ना उसको फाइल शेयर कर आपने बोला हुआ है तो शेयर करना
हाँ शेयर करो।
ये पावर पॉइंट ये वाला कर लेना लेक्चर 7 लेक्चर 2
और नहीं, अब हम बोल चुके हैं अब ये वापस यहीं से है।
आपके बंदे शेयर
अच्छा। Hello? Am I audible to all of you? Hello, Mr. Chandu, Manikanta, Nagalya. I have just shared one slide. So some of the from one of our initial lectures. Am I audible to all of you? Hello? If you want anything else to say, please. I just now spoke about the cis-trans isomerization and also about the cis-trans isomerization followed by cyclization, and also I discussed about the what we call it as a photochemistry of 1,4-diene. And this is another slide where the what I try to show over here is the photochemistry. I mean the in the case of Norris type 2 reaction, cyclobutanol, which is one of the most important product, one of the most attractive product, and but the yield of this product is very low in the normal normal reaction condition. So the people have tried to make attempt to how to increase this product. So what they have done is they have made the reaction in the presence of uh, organized media like cyclodextrin. The inclusion complexes have been made by encapsulating ketone into the cyclodextrin cavity. Now this is the inclusion complex of the ketone in cyclodextrin cavity, and it is now that this ketone is under constrained media, mobility is restricted. It is now and now it is also set for abstraction of gamma hydrogen, the alpha, beta, gamma. Excited carbon in the presence of light can abstract gamma hydrogen to generate 1,4-diradical, which will combine to give cyclobutanol as the one of the most important product in this case. Yes, hello. Hello, am I audible to you? Is it clear? Any other clarification, please? Hello, on organic photochemistry, discuss initial lectures were on principles of photochemistry. Later on, we have discussed the uh, photochemistry of different chromophoric compounds like alkene, then 1,4-diene, 1,5-diene, carbonyl compounds, alpha beta unsaturated ketone, beta gamma unsaturated ketones, photochemistry of aromatic compounds, photochemistry of what we call it as the named reactions. We also discussed photo-induced electron transfer reaction, homogeneous photo-induced electron transfer reaction, heterogeneous photo-induced electron transfer reaction, different examples of many examples of these chromatic compounds. I am sure you have gone through all the lectures, and if you have any clarification or if you have any doubt, please discuss here. This session is for interaction with the students who are finding any difficulty in understanding my lecture in organic photochemistry, describing all the way from basic principles of photochemistry to all the way to different steady state photochemical reaction. Please come forward and ask some question clarification. I just came to know that the assignment third and fourth and fifth are very critical, and they need some supporting material for this. Hello? Hello? Any, could you please, if you want any, okay. What is this? What was yes. Okay, so shall I share a few more slides about our lectures, or is not necessary? Please let me know. Okay, so this is another slide about the noise type 1 reaction. Here you can see the alpha. There are two alpha carbons here and here. They are one alpha carbon is dimethyl substituted. Other one is so this is going to this will undergo type 1 reaction, alpha bond cleavage. So it will undergo preferential alpha bond cleavage to give you more stable carbon center radical, which are due to this is a tertiary radical. If we cleave this, it's going to give a primary radical. So this will not form. This will form and lead to ring expansion product and decarbonation product and so on and so forth. So, and again, these are the two exceptional cases. Radical on the cyclopropane is not will not generate. So this will not generate. It's going to give a less stable. So this will cleave. Although it is a primary radical, this will cleave to give the product. Another, this is okay. A radical adjacent to the cyclopropane is more stable. This will generate and lead to the product. Again, radical on the sp2 hybridized carbon will not form, and this will cleave. So this will not cleave. This will cleave to give the desired product, and so on and so. So like this, we have a lot of examples based on. So these reactions have been extensively studied by taking different substituents, and you can see this gives a lot of very interesting reactions and so on and so forth. You can see here cyclohexyl with two cyclopropane ring as a substituent, and now at the end of the reaction, both the cyclopropane ring is the part of this. So you get a macrocyclic ring system, a 12-member ring. So this is a very interesting rearrangement in this particular case. Okay. Hello. Anything else? So we're just nearing to close because we're just completing our time. Any more clarification, please? Any question or hello? Hello, participants. So thank you very much for interacting with us here today, and all the best and good luck. As asked by one of the attendees that the assignments, I will just look into this, and if you have uh, any more query, please let me know. Where we are going to just close down our interactive session. Hello. Okay. Yes. Simple now. Yeah. Okay. Thank you very much. Okay, goodbye. Thank you very much. Bye.